The EXP-800 handheld analyzer is laid out to be easy to learn and simple to use. An integrated thermal printer is located at the top of the analyzer with an LCD screen and control panel below. The printer is used for printing out test results, which can then be shared with your customers. The printer only uses thermal paper, so there are no ink cartridges or ribbons to maintain. The LCD screen and control panel are located below the printer assembly. It displays the options you select using the buttons on the panel. Two soft keys are located at the top of the control panel. Their functions will vary depending on what mode the analyzer is in. The arrow keys are located in the center of the control panel. With these keys, you can navigate the menu screens and highlight the icons. The temperature sensor and IR data transmitter are located on the bottom of the unit. The spring-loaded slot on the left side of the analyzer is for a standard data card. It is recommended that you always leave a data card in the slot. Not only will the analyzer use the card to read and write data, but it will also prevent dirt and grime from collecting in the slot as well. The 6-pin connector for the battery test cable attaches to the bottom of the analyzer. To connect the cable, align the arrow on the connector with the arrow on the analyzer housing. A laminated reminder card describing the connecting-disconnecting process is also attached to the battery cables. The EXP-800 uses 6 1.5-volt AA batteries for testing batteries discharged down to 1 volt. The internal batteries also power the analyzer when the menu is active but is not connected to a battery. They also power the analyzer's internal printer when testing discharged batteries. The EXP-800 uses a series of menus and icons to help you find the right option at the right time. Icons are displayed within a series of menus, with 3 icons per screen displayed in the selection area. A menu title bar is located at the top of the screen. An internal battery status indicator is displayed at the left end of the title bar. Many menus have multiple screens. A scroll bar that is displayed on the right-hand side of the screen indicates there are additional screens. The menu screen arrows displayed at the bottom of the screen will show you which keypad arrow to press to highlight an icon, character, or item in a list. When the analyzer is first connected to a battery, a voltmeter is displayed in the lower left corner of the screen. Soft key functions are also displayed in this area, as well as on the right-hand side of the screen. Be sure to always wear eye protection before beginning the testing process. Make sure all accessory loads are off, including the air conditioner and the ventilation system blower fan. Place the vehicle in park. Turn the engine off and set the parking brake. To minimize any parasitic drain on the battery while testing, make sure the vehicle doors are completely closed. Now you're ready to begin testing. Connect the red clamp to the positive terminal and the black clamp to the negative terminal. Rock the clamps back and forth to ensure a positive connection. If the clamps are reversed, the analyzer will display an error message. The EXP-800 draws power from the battery being tested, and it will turn on once the cables are connected. Select the language you would like to use. When using the analyzer for the first time, select Unregistered User. Select the battery test icon in the main menu and press the Select Soft key. Next, you will be prompted for the battery date code. The date code can usually be found on the battery label. Using the arrow keys, enter the date code into the analyzer. If the battery doesn't have a date code, press the Next Soft key to skip this step. Determine the location of the battery by selecting Out of Vehicle or In Vehicle. Next, select the battery post type: top post, side post, jump start post. Top post batteries are commonly found in most automobiles. Side post batteries were extensively used in vehicles built by General Motors. Jump start posts are used for jump starting vehicles with batteries that are mounted in difficult to reach areas. Now you are prompted to select the type of battery you are testing. In addition to testing lead-acid car batteries, the EXP-800 can also test AGM, absorbed glass mat batteries, marine starting batteries, motorcycle batteries, and lawn and garden batteries. For motorcycle batteries, the analyzer asks for the battery part number. For other battery types, you will be asked to select the battery's rating units. These options include cold cranking amps, CCA, cranking amps, CA, marine cranking amps, MCA, Japanese Industrial Standard, JIS, Deutsche Industrie Norm, DIN, SAE, which is the European labeling of CCA, International Electrotechnical Commission IECA, and Europa Norm EN. This information is usually printed on the top of the battery. Using the arrow keys, enter the rating number and press the next soft key. The last step is to measure the ambient temperature of the battery. Hold the bottom of the analyzer approximately 2 inches above the battery case. Once the temperature is stabilized, press the next soft key to continue. The analyzer will now begin to test the battery. Once the analyzer has finished, the results are written to the internal data card as well as printed out using the integrated printer. The battery decision is also displayed through a series of results screens. The first screen displays the battery decision, the measured voltage, the measured rating, the selected rating, and approximate battery temperature. The second screen displays a return authorization code for replace decisions. The final screen displays the battery's state of health. State of health represents the measured condition of the battery compared to when the battery was new. A good battery decision means the battery has tested okay and can be returned to service. Good recharge means the battery can be returned to service once it has been fully recharged on a diagnostic charging station. If the battery does not have sufficient voltage for testing, the analyzer displays a charge required decision. Charge the battery on a diagnostic charger and retest once the charging process is complete. Failure to fully charge the battery before retesting may cause a false reading. A bad battery will result in a replace battery decision. However, it may also mean there is a poor connection between the battery and the vehicle. Thoroughly clean the battery connectors and retest the battery. If a battery has a bad cell or cells, the analyzer will render a bad cell replace decision. Do not attempt to charge a battery with a bad cell. Batteries with bad cells could explode. A marginal decision indicates the battery may fail under extreme climate conditions. A 24-volt decision indicates that a 24-volt battery has been detected. A system test will first evaluate the battery, then the starting and charging systems. This is to eliminate the battery as a possible source of starting or charging problems. To perform a system test, the battery must be connected and in the vehicle. To begin a system test, highlight the System Test icon and press the Select soft key. The first part of a system test consists of a standard battery test. If the battery is in good condition and fully charged, press Next. The analyzer will prompt you to start the vehicle's engine. Following engine start, the analyzer will write the data to the data card and display the results using two screens. The first screen shows the starter decision, average cranking voltage, and cranking time in milliseconds. The second screen consists of a graph depicting the starting voltage across time. Following the starter test, the analyzer can render one of 5 possible results. A cranking normal decision means the starter voltage is normal and the battery is fully charged. A low voltage decision means the starter voltage is low and the battery is fully charged. If the starter voltage is low and the battery is discharged, the analyzer will render a charge battery decision. charge the battery using a diagnostic charger and retest the starter system. Allow the battery to completely recharge before attempting to retest. For a replace battery decision, replace the battery and retest the starter system before testing the charging system. Following a successful starter test, press the next soft key to proceed to the charging system test. The analyzer will test the output of the alternator at idle. You will be prompted to turn off all vehicle loads, such as the interior lights, radio, and ventilation blower fan. Press Next once all of the vehicle's electrical loads have been turned off. Gradually increase the engine RPM until the analyzer directs you to hold the rev level. Hold the engine RPM for 5 seconds while the analyzer gathers system data. Once the engine rev data has been detected and gathered, idle the engine. Press the next soft key to continue. Now, the analyzer will test the engine at idle and compare the data to the other readings. With the engine idling, turn on the headlights in high beam mode and the ventilation blower fan. Once the loads are on, press the next soft key. Now, slowly increase the engine RPM until the analyzer prompts you to hold the rev level. After the analyzer has acquired the system data, idle the engine and press the next soft key. The analyzer will now complete its final analysis of the charging system data. When complete, you can turn off the vehicle loads and the engine. Press the next soft key to write the information to the data card and print the test results. Charging system test results are displayed in 3 screens. The first screen includes the alternator decision, loads off DC voltage when the engine is revved, and loads on DC voltage when the engine is revved. The second screen displays a graph showing the normal DC voltage range and DC voltage with loads on and off. A graph of the diode waveform and the measured peak-to-peak AC voltage is displayed on the third screen. Following a successful system test, the analyzer will render one of 4 decisions. No problems indicates the alternator is performing normally, and no problems have been detected. If the alternator is not providing a charging current to the battery, a no output decision is displayed. A low output decision means that the alternator is not providing enough current to power the system's electrical loads and charge the battery. High output indicates the alternator output is exceeding the normal limits of a functioning regulator. The analyzer may also display one of 4 diode decisions. An excessive ripple decision is caused by one or more diodes in the alternator not functioning, or there is stator damage. An open phase decision indicates an open phase within the alternator, and the alternator should be replaced. When an open diode decision is displayed, the analyzer has detected an open diode within the alternator. The alternator should be replaced. A shorted diode within the alternator will trigger a shorted diode decision, and the alternator should be replaced.